Hi and welcome to our very exclusive EOS booth walk live from Formnext 2019. I'm Hannes Gostner, I'm responsible for metal systems at EOS, and I have here with me my colleagues.
Tim Rüttermann, I'm responsible for the Polymer division, so we take care of all the materials and the systems. And with this I hand over to my colleague Martin.
I'm Martin Steuer and I'm running at EOS the software division. So I'm taking care of everything around coming from the idea through the CAD preparation up to that the file is up to our printers and in full production. And now we wanted to begin at how we are capturing ideas and how are we converting ideas into CAD files and then getting full printed files. So our first booth area here is computer-aided manufacturing. We have our own user interface so that we can drive in the best way our machines. As you can see here, everything including the exposure strategies. You have overview about your parts on the right side. You are getting an overview in terms of also the build plate. We are supporting all our different machines with visualization of what are the areas of exposure. As Rüdiger is showing it, you can select the different machine types, and we are leading with our user interface through all these steps. So it's intuitive in terms of starting from the import, placement, segmentation, exposure strategy, doing the KPI. And to be very flexible, we have our own user interface, as I was already mentioning. And what is also very important for us and for you, our customers, is that we are also integrating our technology into your environment. And therefore we were driving in the last years the development of integration into the most important CAD/CAM files and CAD/CAM systems, like we are showing here with Siemens NX, which is one of the... It's not working, sorry. So we are having the integration into the most common CAD/CAM systems like Siemens NX or Autodesk NetFab or also PTC and Creo and CATIA. So we are fully integrating our functionality into this environment, and the biggest benefit for you as customer is that you are able to work in one environment. So driving your idea, developing the geometry, and then having immediately always at your fingertips all the manufacturing relevant information. To get an overview which kind of integrations we have, on the other side of the stand we have all the integrations we are currently doing. As I was already saying, with Autodesk into NetFab and into Fusion, we have Siemens NX. We have also with Dassault 3D Experience. We are working with PTC in terms of Creo and a couple of others. Also important for us is that you are experiencing your parts before they are becoming real. So instead of going to the machine and waiting for the result, we are working with companies like Additive Works or with ANSYS in terms of process simulation, so that you can experience the part, how it will behave on the machine before you are going on the machine. And another important thing for us is also that you can secure your intellectual property with digital rights management, so that you can protect your files from the beginning up to the end, and also be able to control how many parts will be printed on the part.
All right, now when you have prepared your job, then you can build nifty things, like for instance this very nice part that we have built with our newest machine, the M300. The M300 is now being shipped to our first customers, and as you can see, you can build pretty big parts with very intricate geometries and very nice surface quality. That's the beginning of our new machine. Now,
I have one other cool idea because we are just standing here. One of the important thing is also to help you to get your parts very fast and accurate on the machines. We are also taking a lot care about serviceability and calibration our parts. And one of the cool stuff we developed in the last year is what we are calling Smart Cal, which is our calibration blade, which is enabling you within hours or minutes to calibrate the machine so that the lasers are meeting actually the right points at the right time. This is a big time saver in terms of setting up the machines and also boosting your productivity so that the machines are way higher available than in previous times.
And also to add on that, also quality control is very important because you can get all the data, you can store them for quality reasons, so you have a digital control about your calibration process. So Smart Cal is really a top tool and people love it, and also our service technicians and our customers really love it. So Smart Cal was one of the greatest innovations we had also in the last year, and it will be fully extended to all the machines, and I love this product. Good. So parts.
Let's go now to the shared
Materials.
workers.
No, materials.
Good.
Materials. So, because the machine, the software is important, in the end you also need a material to build parts. And the part properties is what is important. So, this year we have a bunch of new materials thanks to our metal materials division in Finland. And I think there are some very exciting ones among them. And it's really a wide range of new materials. So we have different new high-strength aluminium alloys, 7000 series aluminium, 6000 series aluminium. These are still at an early stage, and we want to engage customers to work out which kind of alloy is suitable for which kind of application, so that we then develop things further together with our customers. Then we have also new titanium alloys, different grades, and also a new alloy, the Ti 6246. Then if we look a little bit further, we have also something completely new, and that is copper alloys. And all of the materials, I should say, are available for the M290, making the EOS M290 the most robust and most flexible additive manufacturing platform out there. For metals, of course. Polymers is a different story, but for metals, it's the most robust and flexible. And you see, so we have commercially pure copper with the highest electric and heat conductivity, and then slightly less pure copper for which you get better mechanical properties and better build rates with some loss on heat and electrical conductivity. So as usual, it depends on your application what alloy will be right for you. So also on nickel-based alloys, we have some news. We have Inconel 939 and the 282, which is popular in North America. So they are even more heat resistant than the well-known Inconels 718 and 625 we already used to have in our portfolio.
People love the Inconels, and even 939 is totally new. And this was, maybe it was hard to weld, but we managed to have also now an Inconel 939 on the market. So this is incredible, and people love this material, also because of their high stiffness and strength in the temperature, high temperature range.
And thanks for mentioning it's hard to weld, because that's actually true for most of the materials you see here, and that's why it's really great that we managed to develop all these different materials, even though they're so hard to process. And the same is true for these steels. So we here have a hot working steel, H13, that is used for die casting, for instance. We have super austenitic, super duplex steels. All of these are very hard to weld. and well, it was quite a development, and it's always great when something hard finally leads to results like this.
An important thing also to mention here in terms of data preparation is that we are developing together with our process department all the exposure strategies, and we can implement very fast different kind of exposure strategies within EOS Print, which we are then also providing into other CAD/CAM systems. So with all our software packages, you are immediately getting the right process parameters for our machines, which are providing you this kind of quality. And next we wanted to show you our whole automation, so what we are calling the shared modules, going into full automation of an AM production. And let's go to the podium so that we can give you an overview.
And about this, I have to say I'm especially pleased because we have been talking about the factory of the future for some time now, and this year it's actually here on the booth. So we have been developing the shared modules concept, our automation, in the Next Gen AM project together with Daimler and Premium Aerotech, and now we have the serial hardware here on the booth. So that's our vision of the factory of the future, and it's not a prototype, it's not a mock-up, it's the real thing. So the only downside is because the Wi-Fi connection, the fair was able to offer us everything is moving slower than it will in a real factory. So that's a little bit unfortunate, but apart from that, it's working like a charm. Maybe you can you actually see the exchangeable frame moving? I don't know if you can catch that with a camera, but it is moving. And then next, this little red AGV will lift up this inert gas container and then start moving. So the idea here is that by automating the transport of the exchangeable frame, you increase the productive time of the process chamber. Yeah, so basically you get more laser on time. Okay, now you see it moving, that's nice. So we move the exchangeable frame about in this inert gas container between the process station, which is on the right of this installation, and then the unpacking station on the left. Yeah? And so you can unpack and process the next job in parallel. So this is the high-end version. There will also be a simpler version, not with an inert gas container, just with a dust-tight container for customers who don't need to have inert gas securely all the time. Yeah, it's a question of your requirements and of course cost. But anyway, now it's moving again. Maybe that's nice to see. With this, you can significantly reduce cost per part because the utilization of the process station is much bigger than without this automation.
The question now is, who controls that? And maybe Martin,
yeah,
it's your turn.
So as we started now with the setup station, where the job started goes into the inherent gas container, which is bringing it to the process station. As Tim and Hannes were already asking, how are we controlling that? And for that we developed our EOS Connect control center. EOS Connect is the software family which is giving connectivity, but also is doing automation and controlling the whole AM cell. This is the dashboard of EOS Connect Control Center, and you can view and see where are currently the parts as the AMG is currently driving from the setup station up to the process station. Other important information are available at your fingertips in terms of also telling you which messages were submitted from the system or from the different stations. As we have here the setup station, it was saying that the job is now unloaded. That was what you were previously saying. So our control center is giving the whole management of the job from one area to the other. The important information also here is that we have all the APIs and connectivities so that we can connect that to MES systems and PLM systems so that the AM cell can receive jobs from higher systems, can process them and can bring them back into the high-end MS systems.
And there's also a web interface for that, so you can check your machine park on your smartphone while sitting in the train. Yeah, so it's really nice. And I think we first showed that in a video like 2 years ago, and now it's here.
Can you elaborate a bit on the two fundamental connections?
Yeah, that is just something I wanted to say. So EOS Connect has 3 different modules. The base module is what we are calling EOS Connect Core. It is sitting in the machines and it has 2 interfaces. One is a web API where you can access all our data within the data base. So sensor data like oxygen level, laser power, inherent gas levels and other things, which you can pull from the machine in your MES system or others for upstream calculations. And the same thing we are providing through an OPC UA interface where we are live streaming all the relevant sensor data for further use. And EOS Connect Core is the base for it. And then with Control Center and Machine Park, we are building on top of that the apps to drive our different systems, the process station, setup station, unpacking station, docking station, and so on, to provide you a complete solution to automate the AM cell.
Industry standards, really?
Yes, we are using industry standards with OPC UA and with an REST API to give you access to our database. And we are also looking into which other industry languages are more and more commonly used. Things like MT Connect and others are on our plan. Yeah.
Okay, so good.
Let's go down and see what we are doing in terms of monitoring, so job quality reports and so on, onto our next booth.
That means we already get a lot of data from the systems, but now even more fundamental insights into the process now.
Yeah.
Let's have a look.
So we are calling, that is the third software application we are providing, our monitoring suite, which we are calling EOS State. It is actually consisting out of 3 modules. EOS State Base, that is for getting job quality reports to tell you that the job was running well, how many messages were coming, and giving you a complete report with all relevant data. On top of that, we have EOS State powder bed, which is controlling that the machine is doing the powder recoding in the right way. And then what we want to show here is especially EOS State Exposure OT, our optotomography monitoring solution, which is giving you insights into into each layer in terms of if you have overheating, underheating, or other kind of problems which could add up in higher layers. So through watching through each of the layers and getting the relevant informations, you get a very good insight if your part was printed very well, and through even 3D visualization. So here you are seeing it in 2D, each layer after the other. It is giving you indication because we are providing also some base algorithms to detect overheating or cold spots in certain areas, and then you can investigate it with an intuitive interface where are these areas, and then you are able with the upper part of the application to watch or to look after if there are certain problems occurring also in the layers underneath or higher, so if it is self-healing or not. You wanted to say something, Tim?
That is an industry-proven method at certain companies. Also
Yeah. Thank you, Tim, for reminding me on that. So this is actually a development together with our customer MTU. MTU is using that already in full production, and we are currently rolling it out in other aerospace industry customers, and they are using it for three purposes. One is for quality assurance, so once they have an application which is already certified in Insight, but now we are also using it more and more together with the feedback of customers during the development time. So to speed up development time of an application and seeing already earlier how and what is behaving within the part, so that you are in a better position to adapt your exposure strategies, your parameters in those areas. And one very nice recent development with a partner, we can also visualize the whole 2D data into a 3D picture, which is now on the right side. What's this? Good. Like often, it's currently, unfortunately, it's currently not working. So what we are doing there is we are aggregating all the layer into a 3D picture, so that you can see within the 3D area where critical areas or non-critical areas are, so that you get a faster understanding within your part where it is, instead of having it only as a 2D information.
And I would like to add that I think you did an especially nice job on the user interface. It's so easy to use and very intuitive to find all the indications and to browse through the part. I think that adds a lot to the value of that product.
Yeah, it is now available for the M400-4s in the most recent version.
The M300.
Yeah, and the upcoming M300, and also for the M290s. Yeah. Yes, that is one of the things what Hannes was just saying in terms of having a user interface is very, very important for us. Easy to use and bringing customers and users very fast into interpretation of what the system can deliver. Yeah.
Okay. And if you combine all that, maybe you can now create really nice, beautiful parts in a controlled way. Maybe that's a good chance if we look over to some applications. So Hannes, I follow you. Good. I hand it over.
Thank you. So here we see a few applications. And you see here one focus area is heat transport. So this is heat exchanger geometry that makes use of the immense complexity you can realize with 3D printing. I mean, imagine machining something like that. It's not possible. And with that you get a surface area that is much bigger than in any conventional heat exchanger geometry.
Also some historical applications we have brought. I think it's a technology that's known for centuries.
It's kind of a key application, I would say.
Really a key application.
And it's showing actually this is printed in one part, so it is not assembled, though the full functionality, function integration is within this part, can be printed as one, which is one of the advantages of additive manufacturing, that you can reduce assembly time by printing all the moving parts in one thing.
And you can remove the key, right?
Yes. So a real-life lock built in one part. I think that's pretty neat. Okay, so this is fun. Now I would like also to show you one more serious application that is already in serial production.
Actually, it's not only fun. Myriads of applications you can do, the combinations for turning key, which is otherwise hard to do with other technologies. So that's really nice. But I know you have now a special part which you're really proud of.
Yeah, true. And you're right, it's not only fun, but of course this special part is not a serial production part, it's a demonstrator of the capabilities. Now let's move to a part that is in serial production. and that is this part. It may not look as neat as the lock or the heat exchanger, but it is a real-life application that is flying on the Airbus A350. So it's a latch shaft for the passenger door, and it's in serial production. And Airbus actually qualified this application on an EOS M400-4. And yes, I'm very proud of that, to have the EOS M400-4 qualified by Airbus for a critical aerospace application. I mean, you can imagine these guys are really serious when it comes to the requirements and to qualifying equipment. And of course it wasn't easy, but Airbus, with our support, made it. And this is something I'm extremely proud of.
And as it's written here, it's really so important to show it. It's not only the weight saving, which actually as 16 of these parts are always in an airplane, are helping to save more than 4 kilograms of weight. But also previously it were 10 parts which had to be welded together. So now it is in one part. And the other thing is, again, together with all the software application, having it integrated into CAD/CAM CAE files for doing the data preparation and doing the experience, it helped Airbus to develop these parts way faster.
Okay, we have seen nice applications, but the question now is, how get you there to master these? And that's the time really for consulting and services we offer. And maybe we have a short look at that, and please follow me to the other nice applications. Good. So we are here at the booth part where we show on the services and the consulting. And let's start with our Additive Minds Academy. Because at the end we see all these examples, but we also know there's a way to go until you master these applications. So there we have created with the Additive Minds, there are certain service packages which can help you either from identifying applications, from really doing the engineering of the applications, up to ramping these up. There are certain offers we have. From that I go to the academy. You can see that, like, you can work designing the AM Designer. This is a program we created where we show how you can create complex designs. It is a little bit a funny story because we said maybe bring these new opportunities, lattice design, bionic designs. We said people would immediately adapt it and work from it. What we learned, wow, that's really change management, how you construct things. Also the quality engineers get a little bit crazy. How about all this bionic stuff, how to do quality assurance with that? So that's why we have the AM Designer is one thing where we create how you can evaluate how a part is suitable for AM, how to create really design rules in a new way and how you get there. So it's a mixture always of online and classroom things, because we would like to scale and bring this to the industry. The other one is if you do data preparation, so the typical CAM elements, you can work on how you do prepare things that you can produce them in sustainable quality. All the things, quick and efficient data preparation, recognizing the challenges, how you do that and how you prepare in things in metal and in polymer. So we have certain programs that bring you up to speed and to help you. And I think this is very famous, which EOS, we made that move several years ago, and this was one of the key elements that people really adapt to the new possibilities. So this is the Additive Minds Academy. Plenty of options, just contact us, you can see it. Now, assume you are into production. The question is, sometimes you might need service, for sure. Maintenance, repair, and all the elements. We have created a totally new service approach because we listened to our customers and they said, guys, I need a modular, flexible thing, and that's also why we create certain elements like preventive care. If as a user you want to do your own services, we created the co-services. That means together with our customers we can deal with their servicing elements on their own, and we only help on the tough parts. We have certain elements of that, so it's a complete new picture we created, and the new service elements are really adapted to the customers, and we listen to them. So this is the portfolio which we put around our customers really to make things work.
Just to add one thing, I mean, we experienced that adopting additive manufacturing really requires a paradigm shift in part design, in production planning, in quality assurance, in so many aspects. So these enabling services in our service and additive minds organization are extremely important, and we are also very proud of the expertise we have in these teams that I believe is quite unique and is so vital to really make things happen and use the capabilities of that fantastic technology.
Good. I think this is metal, software, and software is always the gluing element between us. And we will also experience now if we switch to the polymer division. So let's maybe go over. And I will introduce you to the world of polymers. Good. So the polymer world it all starts with applications. And in the last 2 years, we have seen a dramatic increase of serial applications, which we can do in the polymer domain. And this is really a nice thing. And at the end, you might think of at the end, it's only about the machine. Actually, it's not. It's about the application, it's about the material, and at the end, it's about the system. And we have EOS, we have been focusing on bringing different exposure technologies to the market that suits different needs. And one of the standard things we are doing is selective laser sintering. So the classical laser-based approach with a scanner unit. And already there we have great applications, also serial applications like automotive. And there's always the element, this is running nicely. And our customers really deploy our existing portfolio even more and more in serial applications. But we also showed last year a new element if it comes to productivity, because injection molding is the ultimate goal where we strive for that we can complement this technology. But at the end it's about speed and how we can do that. We introduced the laser profusion technology, which is also we can show certain parts which get in the range typically to 9 seconds really to produce these parts with a nice surface. This is a future technology which is some way ahead. But if you can look at it, the principle is totally contrast. We don't use one laser, not 2 lasers. We use 1 million lasers in that. So we use a diode array, which you can deploy in a platform machine. And that's the fundamental concept we show here. We have developed a platform that can deploy different light engines. And we have the selective laser sintering. It will be able to use the laser profusion. And there's one highlight we show at this booth. We introduced the technology of fine detail resolution. And fine detail resolution means we have a different optical setup. And with these things, you can create parts that have a really nice detail resolution and a surface quality that's beyond what you know from powder bed fusion elements. With that, we are stepping one step closer towards injection molding. And you can see these parts as printed. You can see the functional integration stuff. You can scale it, and even in the small size, you can see the details, and it's working nicely. And you know, powder bed fusion has superior properties, maybe against SLA or other things. And with that technology, you can also replace SLA applications because of the nice details and the nice surface quality. And what you can see, if injection molding, this is too complex. Even the tooling is such expensive. So with fine detail, we also see many applications like plugs and all this stuff. And I will show you over which are typical applications. Martin, yeah.
I would not be the head of software if I would not have some information about what software is doing for the polymer systems we have. So in the last year we pushed a lot of new functionality also in EOS Print, which we showed already at the beginning, to especially support polymer specific workflows like nesting, like staggering above it. We have also the full integration into the automation interfaces, MES, so also EOS Connect is supporting the P portfolio, so P3, P7, P8, P9. And another important thing which I wanted to mention is also that we are taking especially care about our machines, that they can go on a shop floor and are not easy to hack or are really good protect, in that way that we are paying a lot of attention to product cybersecurity, which means we are scanning our software for any vulnerability. We are applying all the software patches which are coming from our providers like Microsoft and other things to provide you the highest security you can get in terms of getting these machines and connecting them to your operating systems. That's where EOS is standing for, to go in high-end production environments and providing the right systems and tools to enable you to get into production.
This was a clear statement. EOS takes care for the existing portfolio, even the P1, P3, P7, P8. These are really, really well-selling and best-selling systems. And we see more and more they are moving to production. That's why also we strengthen them on the software side. So it's not only about a new platform, but also for the existing platforms. But the beauty of Polymer is in the applications. So let's have a look at some FDR applications, fine detail resolution applications. Oops, sorry.
So Tim, these FDR applications, are they really mass applications or very niche ones?
Typically, whenever I talk to customers, they feel really excited. So I have something like from niche, but even to mass applications. Okay. If you think like certain housings or electrical or plugs for that, what you can use. So this is, there are a lot of applications, and look at the fine details you can create with that. This is really a game changer regarding surface and detail precision. Also, if you look, maybe elements that combine fluid channels or whatsoever. And the nice about this technology is you can reduce wall sizes down to 220 microns. And also we reduce the spot size of the laser compared to the Formiga or famous high detail system by 50%, even lower. So this creates totally new applications.
How thin the walls are, and I'm really also very excited about it. As I'm a model engineer, really FDR is giving us with some SEL as the capabilities to do very, very fine resolutions and getting also into new applications like model engineering and other areas.
Yeah, and so people are really excited about this. So we are here to show it, to discuss with customers, and then we will make the technology available. But we would like to base this on real customer feedback. That's why we are here. And let's head over. This is a nice example of functional integration. So this is a testing device printed all at once for valve systems. And typically for that you had to create all these different parts you had to do, and you had to print them differently. And now you can print them in one and just assign them. You see all these clumsy elements can be directly printed in one system. One topic that's becoming more and more important is coloring and also surface treatment. And we have some partners also in our ecosystem, which you can also see at the Dimension booth, a new system really showing nice surface treatments. We have white parts, you can easily color them, which is used by many of our customers to date. Or you can create textures at the surface just by using the software and also combine it with coloring. So these are really going into nicely finished elements.
Especially the smoothness of the surface,
Right.
which we can reach now.
And this is what we can do with the existing materials, like call it conventional PA11, PA12. So also the new fine detail resolution is totally compatible. You can use your existing powders. It's only a different machine setup we're going to provide. But there's also, if you're going to high performance polymers, this I would like to show you at one of the last elements. If we step over, this is the topic of digital foam. You might say, digital foam, what's that? And that's exactly what it is. We can create sponge type elements and foam type structures by just producing them either by material properties, but especially by geometrical properties. And for this you can create customized, really personalized elements, like for helmets, which you can use. So you can create these structures, combine it with existing elements, which gives a much better damping behavior. And this was tested with customers in our professional teams. Footwear, definitely a topic.
And what is nice through our platform architecture within software, that these kind of helmets where you have lattice structures which have inside a different damping behaviors than on the outside, needs to be calculated for each head different. And what we did with our partners, like with Anthropology, other things, to provide them an interface that they can immediately, out of their application where they are calculating these lattice structures, they can generate the printing files and getting out of this environment immediately the right print file to our machines, fully prepared, so that the operator at the machine only need to load one file and can print in a very high efficient way these kind of helmets.
Then the ultimate approach, pack materials, so high strength polymers for high temperature usage. So typically we have new on the booth a neat pack. That means that it's an unfilled pack where you can create really stiff structures, which are used mainly in the aerospace applications, or wherever you need high durability regarding temperature. You can combine it also with carbon fiber based elements, so really interesting applications like in the aerospace or whenever you need high mechanical stability under high extreme temperature conditions. We have a variety of materials which I don't want to go in detail. Just come to our booth, discuss applications with us, and to see where this might all help you from the idea you have, from the cut file. We can help you on producing these parts, we can train you, and at the end it's about the applications which can take part in this large polymer market of injection molding, and we are stepping more into more applications where 3D printing comes into serial production. And that's our mission at EOS. That's the mission of Hannes, that's the mission of Martin, and it's my mission. Really, we would like to bring 3D printing into industrial applications and production. And that's where we stand up every morning to make our systems reliable, to bring properties out which are repeatable, and to bring really things from the digital thread in that you can produce parts and sleep well at night.
Sorry, Tim, I have to add one thing. We not only want to do it, we are already doing it, and that's the nice thing. I mean, of course we can't talk about all the applications of our customers, but there are serial applications in polymers, in metals. It's happening, and I hope we can show you that with all the new products we're showing here, even more will happen, because things become cheaper, the enablement becomes better, and also the variety of materials and processes becomes for.
It's not only that we the machines, but we are out taking a high you experience long writers with
Eins. Eins. Eins, 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 zwei, drei, vier, fünf. Das ist ein eins. Eins, zwei, drei. Test eins, zwei, drei. Eins, zwei, drei. Eins.
Danke euch.